Hello everyone, welcome back to the Liceo Math Club YouTube tutorial. I am Sian, and I would like to give credits to my partner Ludwig Van Bulan for making this PowerPoint presentation possible. And for today's lesson, we're going to talk about the conic sections, the parabola. Geometrically, it is a set of all points which are equidistant from a fixed point called the focus and a fixed line called the directrix. It is formed from cutting a cone parallel to its lateral or slant height. As you can see on the right side, we have the circle, the ellipse, the parabola, and the hyperbola. Algebraically, it is the graph of the quadratic function quantity y is equals to x squared and the square root function quantity y squared is equals to x. We are going to proceed to the parts of a parabola. So a parabola has the following. The vertex. It is the minimum/maximum point of the graph itself. The focal point. It is the fixed point of the parabola. The directrix. It is the fixed line of the parabola. The axis of symmetry. It is the line where the parabola splits in half. The latus rectum. This is distance from any point from the parabola to the focus and is denoted by 4p. And now, we are going to review the quadratic functions in the vertex form. Any quadratic equation in standard form is y is equals to ax squared plus bx plus c and can be transformed into the vertex form y is equals to a x minus h quantity squared plus k. Rearranging the equation so that the squared term is isolated, the equation becomes x minus h quantity squared is equals to 4p quantity y minus k with 4p equivalent to 1 over a in the vertex form. This is the standard equation of any parabola used in graphing. A parabola can be horizontal or vertical, and to determine its behavior, we can use this general form for conic sections. Ax squared plus by squared plus cx plus dy plus e is equals to 0. A parabola is vertical or facing upward or downward if the x squared term is present and the y squared term is absent. And a parabola is horizontal or facing left or right if the y squared term is present and the x squared term is absent. So graphing the parabolas. For a parabola to be vertical, it must have the following properties. For the equation, x minus h quantity squared is equals to 4p quantity y minus k. For the vertex, we have v, quantity h and k. For the focal point, f, quantity h and k plus p. And directrix, y is equals to k minus p. Endpoints of the latus rectum, L1, is the quantity h plus 2p and k plus p, and L2, quantity h minus 2p and k plus p. The parabola opens upward if the p is greater than 0 and opens downward if p is less than 0. For a parabola to be horizontal, it must have the following properties. Equation. Y minus k quantity squared is equals to 4p quantity x minus h. For the vertex, v quantity h and k. Focal point, f quantity h plus p and k. And directrix, x is equals to h minus p. Endpoints of the latus rectum, L1 is the quantity h plus p and k plus 2p, and L2, quantity h plus p and k minus 2p. The parabola opens to the right if the p is greater than 0 and opens to the left if p is less than 0. Let's practice graphing. So here are the following examples or problems that we are going to solve. First, find the graph of the quadratic equation y is equals to x squared minus 6x plus 8 and label its standard form and parts. So first, we need to convert the equation to standard form. So we have y is equals to x squared minus 6x plus 8. Since 8 doesn't have any factors, we need to complete the square. So we will have y is equals to quantity x squared minus 6x plus 9 plus 8 minus 9. We will have y is equals to x minus 3 quantity squared minus 1. So x minus 3 quantity squared is what we call the perfect square trinomial. And it doesn't stop there because we need to transpose -1 to the other side. So our final form is x minus 3 quantity squared is equals to y quantity y plus 1. Now, given the equation, we can label its parts. For the vertex at V, we have 3 and -1. So for the 3, we need to get x minus 3 is equals to 0 and transpose the 3 the other side, so we will have x is equals to 3. And for the -1, we need to get y plus 1 is equals to 0 and transpose 1 to the other side, so we will have y is equals to -1. For the focal point at F, we have 3 and -3/4. So for the 3, we just copied the 3 from the vertex. And for the -3/4, we need to add the k and the p. For our k is -1 and our p is 1/4. So -1 plus 1/4, we have -3/4. For the directrix at y is equals to -5/4, what we did is we subtract k and p. So our k is -1 and our p is 1/4. So -1 minus 1/4 is equals to -5/4. The latus rectum is p is equals to 1/4 with its endpoints at L1, 5/2 and -3/4. So how did we get 5/2? We just follow the formula, which is the h minus 2p. Our h is 3 minus 2p. Our p is 1/4, so 2 times 1/4 is 1/2. After that, 3 minus 1/2, so that we can get 5/2. And for the -3/4, we just add k and p. Our k is -1 plus 1/4, which is our p. So we're going to have -3/4. And for the L2, we have 7/2. How did we get 7/2? So we just follow again the formula, which is h plus 2p. Our h is 3 plus 2p, which is equivalent to 1/2. So we will have 7/2. And for the -3/4, we just add the k and the p. So our k is -1 plus our p 1/4. So we will have -3/4. For the axis of symmetry, we have x is equals to 3. So on the right side, you can see the parabola is facing upward. Now, given the directrix x is equals to -12 and the endpoints L1, 0 and 9 and L2, 0 and 3, find the equation of this parabola. So first, we need to find the focus using the midpoint formula, which is x sub 1 plus x sub 2/2 and y sub 1 plus y sub 2/2. We will have 0 and 6. Because 0 plus 0 over 2 is 0, 9 plus 3 is 12, divided by 2 is 6. Since the endpoints are 6 units apart, the latus rectum is 4p is equals to 6, with p alone is equals to 3/2. Next, locate the vertex, which can be done if we get half of the distance between the directrix and the focus. So the vertex is v, -6 and 6. Using the given, the equation becomes y minus 6 quantity squared is equals to 3/2 quantity x plus 6. So this is the directrix, and dislocated x is equals to -12. And this is the focus, which is our 0 and 6. And we need to get the half of the distance between them to get the vertex, which is here. -6 and 6. So that's our graph. So last, find all possible points for a parabola centered at v, 4, and 0 with directrix y is equals to -4 that intersect the line y is equals to 4. First, we must solve for the latus rectum using this given. X minus 4 quantity squared is equals to 4py. Using the equation for the directrix, which is y is equals to k minus p, we have -4 is equals to 0 minus p, and the latus rectum is 16. Now, the equation is x minus 4 quantity squared is equals to 16y. To find all points that intersect the line y is equals to 0, substitute the given and solving, we get that the parabola intersects the line at 12 and 4 and -4 and 4. So this is our parabola. It is facing upward. And before we end, I would like to share this message to all of you, that mathematics may not teach us how to add love or minus hate, but it gives us every reason to hope that every problem has a solution. And that will be all. Thank you!